Good evening, people. I hope you guys can see me. We just have like a 1 minute or something before we start. Oh, I think this phone is making some sound. Just trying to check if everything is fine or not. Okay, can you guys see and hear me clearly? I'm assuming you can. Just type it in the chat if you can. Oh, this is the reason why it was making sound, because I have not connected earphones to my feedback phone. Okay. Let me just check the delay once. Okay, there is a lot of delay this time. Okay, I'm just trying to check if this delay is due to my feedback lagging, or is it delay in general. So usually in the recent days it's been quite real time. There hasn't been so much delay. Let's hear again. Okay, there is a lot of delay this time, so fine, not a problem. I just have to get an idea of how quickly what I'm speaking and when is it going to you and all that, right? So I'll just inform the team. Okay, so do we have everybody here, or okay, yeah, fine. Okay, so yeah, there is delay. I've just been informed about it. That's okay. Okay, it's fine. That's fine. I think I'll be able to manage. Okay, so hello guys, welcome. I believe all of you have been attending these quizzes so far, and we don't really have new members today. In case we do have new members today, as I've always been saying, these quizzes are all about learning. Today happens to be the last quiz of this whole foundation series. So all the people who have attended all these quizzes, I'm sure you guys must have learned a lot about various topics. Like you guys must have got an exposure to your entire syllabus, right? I tried to give you a picture of how your entire syllabus is going to be over the next 2 years. And for those of you who are in 12th, it was maybe just like a nice check of how clear you are foundationally. So that was the point of these quizzes. It was not to check, just like your weekend quiz. It was not, the purpose was not to check if you are answering right or wrong, or who's getting first rank, who's getting second rank. That wasn't the purpose at all. So that remains for today as well, and not just today, for day after tomorrow as well. So fine, guys, so don't take the results to your heart, as I've always been saying. There's no point googling about the questions also, because they're all handwritten by me. And with all this done, it's a maths quiz, guys, so you might need pen and paper. Again, I don't remember the questions that I had formed. I don't really know if there are numericals in this or not, but in any case, you when you're writing a test, it's better to sit with a pen and paper. For Sunday, you should definitely sit with a pen and paper, because you will have logical reasoning, you will have maths, physics, chemistry, everything. So obviously you will get some questions where you would have to sit with pen and paper. Okay, so okay, all right, go get a pen and paper in case you already don't have one. And I think we can now start with the first question on your screen. So here comes the first question on your screen. Okay, so we have to check, read the questions, read the options. The options in real time will be up. Somebody is asking about how much time it delays. Well, that's really doesn't matter now. It was just for me to know the difference in the time of when I'm talking and when I'm speaking. Somebody is saying quiz is not coming. Don't worry, quiz is not coming for anybody right now. If you are able to see the screen and this thing, that's fine. Options will be up soon, and I don't know why this sudden change was made today, but things were working fine until the last few quizzes. There must have been a technical reason, but nevertheless the options will be up soon. So just have a read of the options and be ready, because it will be up anytime soon. I think my video is stuck, so I'll just trigger it in the meanwhile. Right. You guys just attempt the option until then. Yeah, I think I'm up. Right. So guys, what do you think the answer is to this particular question? Let's see. This is a very very basic question, and I expected these many people to answer it rightly. When it comes to a function, remember, function is something which can take only one it can take multiple inputs, but for each input, for a given input, it can only give one output. So what do I mean by this? So let's say you have a function f of x is equal to x square, right? Let's say x square is a function. In this x square, what all values can x take? X can be 1, x can be x equal to 2, x can be x equal to 0, x can be x equal to 3, anything, right? So in your x square, x, which is your input, can be anything. But if you give x equal to 1 as input, what is the output? 1 square, which is 1. If you give x equal to 2 as input, what is the output? 2 square, which is 4. Is it possible that you give 2 as input and you get 2 outputs? No, right? For one given input, you will only have one output. If in f of x equal to x square, if you give x equal to 3, then output will be 9, right? Because 3 square. You can't have 9 and 19 or something, right? You can only have one output for a given input. So your inputs can be as many, whatever is not making the function undefined, all those can be your input. But for a given input, you can only have one output. That is one thing that you have to be very very clear when it comes to functions, right? So with this done, let's move on to the next question on your screens. What is the term used for the following inputs to a given function, right? For allowed inputs to a given function. I just misread it, so I hope you guys can read it properly, and the options will be up soon as well. What is the term used for allowed inputs to a given function, right? And this again should be very simple for 11th 12th guys, right? Could be slightly tricky for people who have just entered 11th, but I think you guys should know this. Even if you are in 11th and you haven't started studying functions in maths, this is one thing that you should know, because maths is not just in maths, right? It's in physics also. So that's the reason why. Let's see how many people get this one right. Okay, so 92% people, that's great. It is domain, you guys are right. So as I told, if you have a function which is like a box, right? In this box you give inputs x equal to 1, x equal to 2, x equal to 3, x equal to 2.5, x equal to 3.9, doesn't matter. You can give inputs, and for a given input, this box will give you only one output. This box can be x square, this box can be sin x, this box can be log x, this box can be x cube, anything, right? But for some functions or some boxes, there are some values, if you give them as input, then the function will give undefined output. For instance, let's say take f of x equal to 1 by x, right? So if 1 by x is your box, can you give x equal to 0 as input? No, because then output will become 1 by 0, which is undefined. So these values which make the function undefined are not allowed in the inputs, right? So if I were to take all the values which are allowed as inputs, then what will I call these allowed set of inputs as? Removing the ones which are not allowed. If I'm taking the allowed inputs, these allowed inputs are known as the domain of the function. So this is the thing that you needed to know. And with this done, you can now we can now move on to the next question, which is here on your screen, right? How is the graph of a function drawn, right? Oh, this is very basic, but again something that obviously you should know, right? And these are the kinds of questions that I've made for this series, things which are basic, but you should like obviously have full clarity about it. So let's see, question number 3. How many people get this one right? Again, I'm hoping for a 90+% on this one, because it's a relatively simpler question, right? Okay, let's see. So there are like it's like 5 more seconds to go. Doing like a 5-minute delay in my mind and then telling you. Right now I'm seeing 3 seconds to go, right? So I hope you get an idea of the delay. Okay, yeah, 91% people. In fact, I chose the wrong option for this, because the option B and option C are very similar, right? So I ended up choosing option C because I thought that is the right answer, right? So you should be very careful while choosing the option. Option B is the correct answer, obviously. So how do you draw the graph? It's very simple. Your function, take x equal to 1 as input, give it to the function, check what the output is coming. Let's say output comes out as 4. Then 1, 4 becomes a point on the graph. Give x equal to 2 as input. Let's say 5 comes out as output. So 2, 5 becomes another point. Like this, keep giving inputs, keep taking the corresponding outputs, keep making the input-output pair like x, y, x, y, x, y, those input-output pairs, and each of them will become a point. Plot those points on a graph paper, and that becomes your function's graph, right? So this is the entire process for plotting a function's graph. I hope it is clear. And now let's move on to the next question up on your screen, right? This is going to be interesting again, more like an introduction to people who, okay, this is again something that you should have known if you must have had calculus in physics, right, by now. So this question is not just from the calculus in maths, it's from the calculus in physics that you have already studied. So I hope that a lot of people get this one right. So what is the process of measuring change in output with respect to change in input, like the ratio of these two? So let's say if you change the input by delta x and output changes by delta y, then what is delta y by delta x known as? Like what is that process known as? And I hope to get a 90+% on this one also, right? Especially second year students, it should be a cakewalk for you. Okay, 54% people, as expected. I believe second year guys have got it right, and first year guys did not pay attention to this point, which is why I brought it up in the question. Okay, so what is differentiation after all? Answer is differentiation to this question. Now you have to think about, okay, what is differentiation? Mathematically, not graphically right now. What differentiation is graphically is a separate thing. I don't know if there must be a question coming up on that, or you will anyway study that in maths. But right now, first you have to visualize what is differentiation. Okay, so let's see. What do you mean by differentiating a function? I take a function f of x. Okay, I will give x equal to 1 as input to this function. I will get some output, let's say y. Okay, now what I will do is I will make a very small change to my input. So what did I give initially? I gave x equal to 1. Now what I will do is I'll give x equal to 1.0001. So I made a change of 0.0001. So that becomes my delta x. X is your input, right? So change in input is delta x, or in differentiation it is also known as dx. If that change is very, very small, then your delta x will be dx. Okay, so that is what you mean by that this dy by dx, whatever you have been seeing, this d of x means very, very small change in x, which is almost equal to 0. It's something like x equal to 1 and x equal to 1.0000000001. That's small, right? So very, very close they are. So if you make a slight change to input, then your output also will change, right? If you were giving x equal to 1 as input, output was y. If you are making a very small change to input and giving, then output will not be y anymore. It will be y plus dy, something like that, right? Some change in y. So this change in y, which is dy, if I divide that with change in x, which is dx, then this dy by dx is known as differentiating the function at the point x equal to 1, right? So you were giving x equal to 1 as input, right? So this is what you mean by dy by dx at x equal to 1. So differentiation means measuring how much the output is changing with respect to change in input, like taking the ratio of these two. I hope the visualization of differentiation is clear to you. Now there is a geometric meaning also, and that we will see. If we have a question on that, we will discuss. Otherwise, pay attention to what is the geometric meaning of differentiation in your physics textbook or maths textbook, wherever you first encounter it. That's all about the explanation for this question. I hope it was informative, and now we can move on to the next question, which are the following: is most appropriate about finding a limit of a function at a point. I think there is an at missing there, but yeah, you guys can ignore that. Again, I don't expect first year guys to really know this, but second year guys, you should know this. If you haven't had clarity about this and you have been studying limits, differentiation, integration and all that, doesn't make sense. This is like where everything should start from, right? And first year guys, again pay attention to what I tell, because you will also have to study limits in the future, right? So don't think that it's not in your syllabus, so it's not important for you to hear. That's not the point of these quizzes. It's for you to get an idea of what is to come beforehand. Okay, let's see how many people get this right. And as expected, 40, 20 right. People didn't have clue about this question. First year guys didn't have clue. Second year guys should have had clue, and that's the reason why I see at least like 40% on the correct response, which includes my response. Okay, what do you mean by limit of a function? First year guys, second year guys, both of you clearly listen. People who didn't know this, clearly listen. What do you mean by limit of a function at a point? Okay, so let's say you take a function f of x equal to 1 by x. Okay, take 1 by x. Now if you give x equal to 1 as input, what will be the output? X equal to 1, like, because 1 by 1. Okay, my function is 1 by x. Again, I'm repeating, 1 by x. If you give x equal to 2 as input, what will be the output? 1 by 2, correct? So this is how you give input and check for output. If you give x equal to 0 as input, what will be the output? Undefined, right? 1 by 0. But what if I give x equal to 0.0001? Then output will be 1 by 0.001, whatever, right? That is not undefined, correct? Or let's say give x equal to 0.1 as input. So 1 by 0.1, which is 10, that will be your output. Give x equal to 0.01 as input. Output will be 1 by 0.01, which is 100. Getting it? Again, give function is 1 by x, give x equal to 0.001 this time. Output will be 1 by 0.001, which is 1000. So when you give x equal to 1, output is 1. When you give x equal to 0.1, output is 10. When you give x equal to 0.01, output is 100. When you give x equal to 0.001, output is 1000. As you can see, when you are coming closer and closer to 0, output is increasing. Like, it's becoming from 1 to 10 to 100 to 1000, it's increasing. So finding the limit of 1 by x at x equal to 0 means going as close to 0 as possible and checking how close, like what number is the limit going close to. That is what it means. Are you getting? What I mean is, keep going close to that point where your function becomes undefined, and check where the output is going, right? So if at all output goes to a certain number, then that number, I can say that roughly at this point, this is the output value. Something like, I'm trying to make an approximation. Remember, limit is an approximation. I don't know the exact value at a given point because it might make the function undefined. So I will try to go close to that point, and I will try to see, as I'm going closer and closer to this point, what is the output going closer and closer to. So this approximation, this is known as finding the limit of a function at a point. Again, this was a very, very, like a vague definition, not the mathematical definition. Mathematical definition is quite complex, and that you will have to study when you study this particular topic in your 12th. And I expect a 12th guys to know this. Nevertheless, enough time spent on this question. Let's move on to the next one. I hope you got to learn something about limits from that. Again, which of the following is true with respect to integrating a function? Now, this should be a simple one for most people, I hope. Let's see how many people get this one right. I spoke for quite long, so I'll just take a break on this one and you guys attempt, right? Anyways, you're able to see everything on screen and on your mobile phone also. So I'll just wait for the response, so that if there is any question which comes up which requires deeper explanation, I should have the throat to explain. Correct. Which of the following is true with respect to integrating a function? Okay, let's see how many people on this one. 93% people. That's great. I believe even the people have gone for 7% people have gone for option A. Option A is right, but yeah, B is also right, C is also right. That is all about integration. Okay, so integration first of all means taking some taking small quantities and adding up to make something. This is again like a very vague schoolboy definition, you could say, not mathematical, but it still makes sense, and what I'm saying is not wrong. Okay, integration means summation. Okay, now also it is the reverse process of differentiation, because differentiation means taking something which is big and cutting it into small parts so that we can analyze these small parts. This is more about differentiation. Integration is, we know the small parts but we want to see the whole picture, so we will add these small parts to make a bigger picture. That is integration. I believe a lot of you guys who attended my foundation series in 10th, like we had this foundation series in May and June, in the month of April and May. There I clearly explained what differentiation and integration is. I believe that is the reason why 93% people got it right, if you remember that explanation. Yeah, so integration and differentiation are opposite of each other, and integration also means tracing the area of a function under a graph. Now this I can't explain in detail right now, but you guys need to know as a fact that all these three are true, right? All the options are true. That's the reason why the answer is all of these. Let's now move on to question number 7 up on your screen. When is a function called a continuous function? Now you will have a separate chapter on this one also. So I'll tell you how your calculus chapters will be. First will be functions, next it will be limits, next it will be continuity, then it will be methods of differentiation, then it will be applications of derivatives, then it will be indefinite integration, then it will be definite integration, then it will be areas, and then finally what was the last chapter? Differential equations. This is all of your calculus, which amounts to 40% of your maths syllabus, right? So continuity is a separate chapter in its own, but I've just picked up the essence of continuity and made it as a question, so that you guys just have an idea to what continuity is. But again, it's a separate chapter altogether. There are so many mathematical properties that you would have to know. Let's see how many people on this one. Okay, obviously people didn't have an idea about this, so that's why people have got it wrong. Nevertheless, all these options B and C, they're wrong. Option A is right. First of all, like very basic, if a function is continuous, then you can draw its graph on a graph paper without lifting your pen from the graph paper, because you have to continuously draw it, right? Imagine this function 1 by x. I don't know, okay, you guys might not know the graph of 1 by x, right? And I can't even show you right now some graph, but my point is, try drawing a graph on graph paper. If you are able to draw the function's graph without having any break points, any breaking in between, When will you have a break? When you lift your pen from the paper, right? So in one of the questions I told you, right, how to draw a graph, like taking input output pair. So put all those pairs, draw the graph. If the function is continuous on the graph and it doesn't break anywhere, that function is known as continuous, right? But how do you mathematically show that a function is continuous? Well, there are a lot of properties, okay? Continuity is a whole chapter, and there are so many mathematical properties which you will study when you study continuity. For now, it is enough for you to know that a function will be continuous if you can draw its graph on paper without lifting your pen from the paper. That's the basic thing that you need to know. So as of now, and yeah, obviously option B and C are wrong, so that you can just check, why they are wrong or whatever. Because if at all a function attains an undefined value, then at that point you will have to, then the graph will be such that you will have to lift your pen of the paper at that point, right? Let's say at x equal to 1 your function becomes infinity. So infinity means function is going to positive y-axis, like it's going all the way. So there you will have to add x equal to 1. While drawing the graph, you will have to lift your pen because you can't draw the line up to infinity, right? So there is a break at x equal to 1. So those functions are not continuous. Only functions whose graph you can draw without lifting the pen and paper, which doesn't attain any infinite value, undefined value, those functions are continuous, right? So with this done, I think we are good to go with the next question. Which term suits a function whose output either increases or remains constant with an increasing input? Well, this is again going to be an interesting one. Well, I know, sir, there are two options which must be seeming really controversial to you, but that is calculus, buddies. That is calculus for you. Calculus concepts are very, very close to each other, and that's why calculus becomes the deciding factor. Calculus is going to decide your, my teacher used to tell, okay, my math teacher used to tell, first year calculus is going to decide your ranks. Repeat after me. First year calculus is going to decide your IIT JEE and JEE mains ranks, or BITSAT ranks for that matter, okay? So these are all questions. Most of these questions are from first year calculus, okay? I've not gone into integration and stuff, which is second year. Okay, obviously, like most of the people were confused between A and B, because what is the difference? If you know the difference between strictly increasing and increasing, then most of you would have gone for option B, which happens to be the right answer. Well, okay, so I'll tell you, there is this function, okay? Imagine, okay, your black box again. Start giving inputs. Give inputs in the increasing order, like x equal to 1, x equal to 2, x equal to 3, x equal to 4, like that, right? Keep increasing the input. If your output keeps increasing, right, then it's a strictly increasing function. If it only keeps increasing. But sometimes it can also happen that you can give x equal to 1, x equal to 2, x equal to 3, it's increasing, but then if you give x equal to 4, 5, 6, 7, doesn't matter, output will remain constant. So these functions are increasing but not strictly increasing. So in strictly increasing function, if your input 1 is more than input 2, then your output 1 has to be compulsorily more than output 2, okay? If your input 1 is greater than input 2, then output of, like the corresponding output of input 1, which is output 1, has to be compulsorily greater than output 2. Sometimes it can happen that even though your input 2 is more than input 1, output 1 and output 2 can still be the same, right? So then your function could be increasing, but it's not strictly increasing. Strictly increasing means the graph should continuously keep going up and up, and increasing means it can go up for some time, but then it can become flat also. If it becomes flat, then for increasing input, output will be the same, right? So this is, I hope the difference between strictly increasing and increasing is clear, right? I really wanted you to know this. Let's move on to the next question. You guys must be realizing I'm spending too much time, explaining stuff, because calculus, boys and girls, obviously, calculus is very, very crucial, okay? Calculus is very important. You can't afford to take calculus lightly, and you can't afford to, if you are aiming for any good rank in any of these exams, these topics, this quiz especially is very, very crucial. That's why I have kept it towards the end of everything, right? Because these are like rank deciding concepts. all these concepts from calculus. So if I line, this should be a simple one. Since I've been giving you some tricky questions in the middle, I thought I'll give you slightly, if I draw a line which touches that, takes a sharp turn. Okay, again, this is not very simple. I know most people are going to get this one wrong, as expected. 67% people have gone for tangent to the curve, and they must be like, what is wrong about this, right? What is wrong about this? Well, it's wrong because tangents actually excuse me, tangents do not touch the curve at sharp points. What do you mean by sharp point? Okay, so you can have two types of curves. One curve is like this, it smoothly turns, okay, and another curve can be like a pyramid, like goes up and comes down, like this. It will have a sharp point. So the line which intersects this point is not a tangent, okay, because first of all, it's not touching that curve, it is intersecting. So tangents are defined only for curves which are smooth, okay, not for curves which take sharp turns. I hope you're understanding, right? It's literally what you're imagining. Sharp and smooth are literally what you're imagining. If a curve turns like this, it's a smooth curve. If a curve turns like this abruptly, then this is a sharp turn. If there is a line which is touching this curve at this sharp point, I cannot call that line a tangent, because first of all, you will learn later, 11th guys will learn later, 12th guys would know that at this point, at a sharp point, the function is not differentiable at all, right? You can't differentiate the function at that particular point. So tangents and all, it really doesn't make sense. You will never hear tangents being used for sharp points. Tangents are always used for smooth curves where they will touch the curve only at one point. So this, what you will call, you can call this as a straight line which intersects this sharp point. You really can't call it a tangent. So this is the reason why I brought this up. Again, slightly difficult. Most of the people got stumped here. But yeah, calculus guys, I didn't want to keep really very easy questions. I rather wanted to keep questions like these which are helping you learn something new. So this comes the last year comes the last one. Again, can't really call this as an easy one. But yeah, just for 12th guys at least you would know, and 11th guys, just go by what your intuition says, because you really don't know what inverse of a function is. But I can't really help it, because you haven't studied maths calculus at all. So most of the topics you wouldn't have an idea about at all. So can't really help that. Just go with whatever comes to your head, and it's good to write anyways. Even if you don't know the answer, you're still getting exposed to some of these things right now. So when you actually study them, it's not going to be that challenging, is it? Right? Because you would know some of these from before. Nevertheless, I'm not promising you any magic or something. You will still have to work hard to learn all these concepts, but it always helps. It scares you a little less when you know it from before. So 64% people, that's good. That's good. Again, I can't go into the depth of explaining what inverse of a function is right now, but for now, all that you need to know is the answer to this question, right? So when you study inverse, right, 11th guys, when inverse of a function comes up, always remember, okay, if I have a function, its inverse might or might not exist. That is the first point. And if it exists, then it will exist under certain conditions. That is the second point. Repeat after me. If you have a function and if you want its inverse, now some of you guys must be thinking, what is inverse of a function? Get that thought of your head. I can't explain it right now. But yeah, you will obviously come across this word called inverse of a function, and these 2 points you should remember, whatever I'm telling right now. So pay attention. If you have a function, its inverse might or might not exist. First point to be remembered. Second point, if its inverse exists, then it will obviously exist under certain conditions, right? It will not exist over the entire real line, right? It will exist under certain conditions. That is 2 points. Inverse might or might not exist. Second point, if at all it exists, there will be certain conditions. And the chapter inverse functions that you will study this will tell you exactly about these conditions that I'm telling. For every function, you will have a separate, like log x, what is the inverse, what conditions, sin x, what is the inverse, what conditions, cos x, what is the inverse, what conditions. If cos x has this graph, what will be the graph of cos inverse x? This is what you're going to study in inverse functions, right? So these 2 points, as far as if you remember it now, that's enough. So with this, I know the last quiz of the whole series was the longest one, and it was meant to be because it was the most important one in maths, in my opinion, right? Not just maths, in fact it was the most important quiz, because you have calculus, entire calculus in your physics also, all your problems, so many problems you have calculus, so it was important. So with this done, see you guys on Sunday now. Be prepared. All these topics that we have, you have the index of the, you have the date sheet, right? So all the topics that are mentioned in that date sheet, just have a quick revision of all that. We will have very pretty easy questions for all those questions, 50 questions, 15 chemistry, 15 maths, 15 physics, and 5 logical reasoning. This is going to happen on Sunday, so be ready for that, and call as many people as you can, or as many friends as you can, because this is going to be, it'll cover everything at once. So I really had fun with you guys, and we will have a final closure on Sunday, where I'll tell you a little more about myself. A lot of you would know, but for those of you who don't, we will just have a slight interaction on Sunday, and Sunday evening we will have the announcement of the first few people who scored the most in these quizzes. Again, people who didn't score, don't take it to your heart, doesn't matter. It was just a game that you had to play and learn, right? But yeah, obviously there are few people who have won, who have performed better than the others in the game, so we will be giving them some goodies and something, and I'll have a personal chat with them. I'll have a video call with them on Sunday evening, so you guys can join in too. We will have some interesting discussions, and you guys also will get to learn a lot from those discussions. I'll give you some tips and all about preparation, so do join in on Sunday, both for the quiz and for this presentation in the evening. And yeah, it was nice spending time with you guys. See you, good night, see you on Sunday. Prepare well, all the best.